All right, this is from the Algebra 1 textbook. Now, I'm actually only doing the first 2/3 of this section. Next year, you guys will do this section and you'll talk about standard deviation. That's not something that's going to be on the 7th grade I Learned, so I'm not going to bother covering that. I'm already going out of my way to cover the 7th grade stuff, but there isn't a mean, median, and mode section in our 7th grade book. So it's been maybe a little bit since you guys have done this. It does come up in the Algebra 1 textbook, but we do need to talk about this stuff because not just because it's on the I Learned, but because we're going to talk about scatter plots tomorrow, and there's going to be outliers, and scatter plots is a way of plotting data, and data is what we're going to be looking at today. So a measure of center is a measure that represents the center of a data set. Pretty obvious. The mean, median, and mode are measures of center, and if you've forgotten, the mean of the numerical data set is the sum of all the data divided by however many data values there are. So if there are 7 numbers that you're averaging together, mean is also called the average, then you would divide by 7. If there's 8, then you would divide by 8. The biggest thing I've seen with the mean is that people will add them up and divide by 2. Well, that's what you would do if you have 2 numbers. But if you have more than 2 numbers, you're going to divide by however many numbers you have. I didn't know until I actually read this. This is new for me. I was putting these notes together for you guys out of the Algebra 1 textbook. I didn't realize that you could represent the mean of a data set by putting X and then putting a bar over it and calling it X bar. I guess that's, I'm not used to that notation. So I guess when you see that next year, you guys will know what that means, or at least you'll have seen it. The median of a numerical data set is the middle number. Of course, you have to line them up in numerical order. That is another mistake I see students make, is they'll just get the data set and start scratching off. You have to put them in numerical order. You can't just start scratching. You gotta line them up least to greatest. Okay. Now, we'll see this in our problems today. If you have an even set of numbers, so if you have 8 numbers, 10 numbers, 12 numbers, the median is going to be the average of the middle 2. Okay. For example, let's let each of these dots represent a number. How many dots do I have? Xander?
7.
Okay, I have 7 dots. Is there a middle dot?
No.
Yes. There's my median. Pretty obvious, right? If I have 9, 11, 13, 3 dots, those are all odd numbers, there will be one in the middle. So when you're scratching off, there will be a number in the data set. So the median will be that number. But if you have an even number of numbers, so I just added an 8th dot, now there is no middle dot. There is instead 2 dots in the middle, 3 on each side. You can't say I'm going to scratch 4 on each side, there wouldn't be dots left. So when you're taking the median and there's an even number of numbers up there, you have to take the average or the mean of the middle 2. This is where you would add those 2 together and divide by 2 because you're doing the average of 2 numbers. So the median may or may not be one of the numbers of the data set. It will definitely be one of the numbers of the data set if you have 7 or 9 or 11 or however many number, odd number of numbers. But if you have 8 numbers, it probably won't be because it'll be the average of those 2. Now, it still could be if those 2 middle numbers are the same. If I've got 20 on this side and 20 on that side, what's the average of 20 and 20? 20. Yeah, add them together, 40 divided by 2, so it's still get 20. So it's possible that it could be a number of the data set, but it's unlikely. Probably something else if you have 2 numbers in the middle. The mode is definitely going to be one of the numbers of the data set. It's the one that occurs the most often. Okay. Now it is possible that you could have no mode if none of the numbers repeat, or if they all repeat the same number of times. So if every number repeated twice, you're not going to say every number is a mode. Just say there's no mode. You could also have more than one mode. If you've got a bunch of numbers and 3 shows up 4 times and 8 shows up 4 times. Well, if they're tied for the lead, you would say both of them are modes. Okay. Just because a number repeats does not make it a mode, though. Just because a number repeats, it has to repeat the most number of times. All right, let's get to it then. An amusement park hires students for the summer. The students' hourly wages are shown in the table. Find the mean, median, and mode of the hourly wages. Okay. Whoa, wait a second. What's going on here? Are you kidding me? What happened? All my dots are off. That's supposed to be there. This is just annoying. Why did it do that? I wonder. That's probably what happened. But why? And this doesn't answer the question of why they like what update would say, you know what? We're gonna take this much out of all the lines. That's just unfortunate. These dots are out of order. This is just weird. You know, I put a lot of work into this for you guys.
Thank you. Thanks.
You're welcome. It's just nice when it works and it sucks when it doesn't. Really, with this word here, what is going on? What is this? Why? Why is this? Why are you the way that you are? Just apparently, some update that was. I'm really a fan of that update. Okay, back to it. Find the mean, median, mode of the hourly wages. We'll start by lining them up from least to greatest. Now, you don't have to do that to find the mean or the mode. I think it's helpful though. So what's the smallest dollar amount up there, Carter? $8.25. $8.25. I'm going to ignore the dollar sign, just write 8.25. What's the next one? Somebody, anybody? Shout it out. Same thing, 8.25. Okay, what's the next one? $8.45. Next one? $8.65. Next? Okay. Man, I would hate to do the books at this amusement park. Everybody's making a different amount. What's the next one? $9.10 next. And next. $16.50. All right. Now you have to line them up to find the median. I think it's helpful to line them up first when you're also finding the mean, because at least when you're adding them in your calculator, you know you're going in numerical order, so you don't have to wonder, did I put that one in? You're going in order. Also, lining up from least to greatest is going to put the modes next to each other. So there's multiple reasons why you want to do this first. All right, so mean's the difficult one to do because you have to type all of it into your calculator. That is the nice thing about having one of these calculators versus the one that Christian borrowed from me, because as you're typing it in, if you make a typo, there's a back arrow. If Christian makes a typo, he won't, of course. Why would he do that? He has to start all over. So tell me what you get. I'm going to need multiple people to confirm this. What do you get when you add them together? I just want you to add them together first. Dawson, what did you get? 77.26. Okay. 77.2. We changed it. 77.2. Thumbs up. I'm getting multiple people say 77.2. Okay, so I'm going to write that down. And I'm going to show you why I'm going to write that down here in a second, because that's going to make the second example we do a lot easier. How many numbers are there, Sky? There are 8. Ooh, okay, 8's even. Keep that in mind as we're finding the median next. So we divide that by 8. And Sky, what does that make the mean? All right, so I'll just go ahead and label $9.65 is the average wage or the mean wage of those employees, those 8 employees. The median, now that they're lined up, we know there's 8, so there's going to be 2 numbers in the middle because 8 is even. And then 2 numbers in the middle are going to be these 2. Of course, you can do the scratching, or you can just use common sense and say 3 on each side. What's the average of $8.65 and $8.75, Christian? $8.70. Yeah, you don't even have to use your calculator for that. I mean, you could add them together and divide by 2, but right in the middle of 865 and 875 is 870. The mode. Is there a mode, Chloe? What is it? Yep, 825 repeats twice. It's the only one that repeats. So $8.25 is the mode. Okay. The next question is kind of why we're doing this. It says, which measure of center best represents the data? So we've got the data lined up there from least to greatest. Where would I find $9.65? If I was just, kind of drawing the arrow, it'd be somewhere here, right? Is that in the middle? These are measures of center, right? Okay. The mode, $8.25, right here. Now, you never want to use the mode as your best representative measure because it's just going to tell you what repeats. It doesn't necessarily mean that's in the middle. That leaves us with the median, $8.70, right there. The median is going to be the one we want to use here. Why is the mean not in the middle right now, Jacoby? Yes, that's exactly right. So we want to use the median, and the reason for that is because there is an outlier. Jacoby, what is that outlier? Yeah, somebody's making $16.50 an hour. Maybe they're working overtime. I'm not sure. I guess that wouldn't make sense if it's their hourly wage. Maybe they've got some sort of special duty that requires them to
Maybe they're a doctor.
get paid more. The student doctor? Maybe. So the reason the mean is not in the middle is because the mean has been pulled up by this outlier, that's $16.50 up there. No, by no means should $9.65 be in the middle of our data. Now, the funny thing is, it is the mean. It is in the middle of that data. What you're not seeing here is all of these numbers lined up, and then 16.5 should be somewhere over here, right? And if I put 16.5 way off the page, 9.65 would be in the middle. But if I just line them up like that, I wouldn't want to use 9.65. I'd want to use what's in the middle. So if there's an outlier, you want to use the median as your best measure of center. If there is no outlier, the mean should be all right. Okay, should be in the middle, shouldn't be pulled up either way. So that leaves us to our next topic, outliers. An outlier is a data value that is much greater or much less than all the other values. In this case, the $16.50 was much greater than any other student's hourly wage. So identify the outlier in the previous example. Jacoby said it was $16.50. How does the outlier affect the mean, the median, and the mode? We're going to see which one it affects the most. Bet you probably already know. So the reason I had you guys add the numbers up, I'm going to use this again. I'm just going to copy and paste this. The reason I like showing my work, especially on these problems, is because a lot of the time I'm going to be asked to then do it again. So instead of adding all those numbers up again, except for the 16.50, I know that if I don't include the 16.50, it's going to be 16.50 less than what it was before. So I'm just going to take 16.50 away from the 77.2, and I don't have to do all the numbers again. Does that make sense? Repeat that. Okay. So the $16.50 is my outlier, right? If I'm doing this again, this time I'm doing it without the outlier. So instead of adding these 7 numbers up and taking the time to do that in my calculator, by writing down what I got when I added them together in the first place, I could just do 77.2 minus 16.5 instead of adding them all up again. Okay, does that make sense? Okay, so 77.2 minus 16.5 leaves me with 60.7. So I would get 60.7 if I didn't include the outlier. Now, if I don't include the outlier, how many numbers does that leave me in the data set? 7, which is odd. Keep that in mind when I'm finding the median this time. Can someone tell me what 60.7 divided by 7 is? Go ahead and round it to 2 decimal places since we're talking about money, Lizzie. 8.67, so $8.67. It previously was $9.65. We already found that out. And that is an effect of how much? How much did removing the outlier change the mean by, Xander? 58 cents. Exactly. And so he's just subtracting the difference there to see what it changed by. Okay. We know the median with the outlier was $8.70. Now we're going to find the median without the outlier. So back, I've already got the numbers listed up here. If I don't include the outlier, that leaves 7 numbers. Now there will be one number in the middle, right there. 3 on one side and 3 on the other. And so $8.65 is my median. So it changed. How much did it change by?
5 cents.
5 cents. The mode was previously 8.25. Did removing the outlier affect the mode?
No.
No, it did not. It's still $8.25. And there was no change, no effect there. Okay. But since the mode is not a measure of center that I want to use to represent my data, unless of course I'm voting on something. If I was voting on something and I was, you guys, like it used to be American Idol, used to do text in voting. Text 1 for this singer, text 2 for this singer, text 3 if the text is 5-digit number. They would do voting like that. I'm sure you could just find the mode, which, did you get more 1s? Did you get more 2s for singer 2? Singer 3 get more? You could do mode that way. But usually when you're looking at a data set, you're not going to be voting on something. So we're going to be looking at mean or median. Yeah, Jimmy? Yeah, so which measure of center was affected the most? It was the mean. Nice job. Yeah. The mean or the average was affected the most. Is that what you were trying to say? Your answer? So it wasn't 58 cents. It was 98 cents. What am I hearing? What is it? 98 cents. Okay. Thank you for catching that. Xander, is that right?
Yeah.
Okay. Yeah, I'm looking there, 65 cents and 67 cents. That's not, yeah, they're almost $1 apart, almost $1. So that's actually a really big change. Removing the outlier brought the mean down by almost a full $1. So if I'm looking at my mean right now, if it's 8.65 or 8.67, I should say, if it's 8.67, 8.67 is in the middle of my data. So it's back where it should be. So if there's not an outlier, you want to use the mean. If there is an outlier, you want to stick with the median, because the median, and think about that. Why would the median not be as affected by the outlier? Why? Exactly. The outlier is going to be either your much, much smaller or your much, much bigger number, right? So it's going to be one of the first ones you scratch away as you're working towards the middle. So it's affected a little bit because it shifts down one, but it doesn't have as much of an effect as what the mean was affected by. Okay. All right. So the outlier will always have the largest effect on the mean. If the data set does not have an outlier, the mean is the most representative measure. If the data set does have an outlier, use the median because it won't be as affected by the outlier. On your homework tonight, there are going to be a couple problems. So there are just going to be some problems where you have to find mean, median, and mode. Then there'll be some problems that say find the mean, median, and mode with and without the outlier. And keep in mind, if it asks you to do that, it might be helpful to write down what you got when you added them together. It might save you some time from adding all those numbers up again without the outlier. All right, let's switch to measures of variation. One of the measures of variation is called the range. Okay, so a measure of variation is the measure that describes the spread of the data, not the center of it, but the spread or the variation of it. Okay, the range of the data set is the difference of the greatest value and the least value. What does difference mean? Owen? Subtract. How far apart is the largest number from the smallest number? So you just subtract them. 2 reality cooking shows select 12 contestants. The ages of the contestants are shown in the tables. Find the range of the ages of each show. For show A, What is the oldest contestant? What's their age, Lizzie? 31. And what's the youngest contestant? Christian? 19. What's 31 minus 19? When you have it, shout it out. 12. So a difference of 12 years from the youngest to the oldest. Deegan?
I think the dots are shifted. Sometimes we put it on Google Classroom. Last year.
When you put it on Google Classroom, it shifted, but my notability changed in my notability too, though, which normally like what I post here, it might look different for you guys, but your dots are fine? No, okay, yeah. Hopefully that's fixed for next year's students. That's because let's be honest, that's who really matters. Next year's students. All right, so we have a range of 12 for show A. What about show B? Who's the oldest person on show B? Owen? Yeah, somebody's 48. Youngest person? 19 again. What's 48 minus 19? Shout it when you got it. You don't have to say like, except you can just actually do it. Jimmy, 20, 21? 29. Okay. So which show has the wider range of ages? That would be show B. Why? Why does show B have a wider range of ages? Xander? There's an outlier. There's a 48-year-old on the show, right? So we have an outlier. So the outlier is going to affect the range as well. So if I'm looking at two data sets, one of them has a small range and one of them has a wider range. The one that has the wider range is more spread out. Or in this case, it's not even really so much spread out as it is you got all these data points over here and you got one old guy, right? So it's spread out, but it's actually very condensed and just this. Did you guys do box and whisker plots last year? Yeah, there's a long whisker pointing out to that biggest term out there, which is the outlier, right? So that outlier. Now, if I'm using data to make predictions, which is something that you really use data a lot for, is make predictions about the future. If I have a data set that's really condensed, that's good for me. That's good for predictions. For example, if I was looking at home run totals for Mike Trout, okay? And Mike Trout, year one hits 30 home runs, 35 home runs, 38 home runs, 32 home runs, 36 home runs, 37 home runs. If you do the range for that, that's really small. I mean, he's always in the 30s, mid to low 30s, right? And so I can make a prediction of what next year's home run total is going to look like. If I'm doing home run totals for some other player and they go 17 home runs, 48 home runs, 2 home runs, 7, could be injuries, could be a lot of different reasons why that would happen, but I have no idea what to expect. So if the data is more spread out, I really can't make a good prediction. You can do the same thing with any sports team, not just home runs. You could do like win totals. If you're looking at baseball, I keep going baseball because baseball uses stats probably more than any other sport. You play 162 games, or not sure if they're going to get that 162 in this year because they're starting late. But anyways, if you got a team that's always winning in the 80s or 90 games, you can make, okay, I'm going to guess 85 games or something. But if you got a team that goes from 60 wins to 99 wins, back to 48 wins to 82 wins, like they're all over the place. That data is really spread out and I really can't make a good prediction. Christian. Yes. All right. Now it wants us to compare the mean and the median of the show, of that show. So this would be show B. Compare the mean and median of that show with and without the outliers. So let's do it one more time. We're looking at show B. Show B has these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 data points right here. Okay, I'm gonna have to scroll down. So can I get someone to help me line those up from numerical order, please? Starting with the youngest person. Shout it out. 19, next. 21, next. Wait, is there a 20? Okay, so before 21. So how many 20s? Just one? Okay, next. Next. Next, 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 next. 32. Next. Okay, so there should be 12 numbers there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or was there 10? There should be 12. I think we skipped a couple. Which two did we skip? Come on, all you guys out there paying attention. Which number? There's 2 25s. And there's a 24. All right, there we go. Do we agree with this? All right. To find the mean, I add them all up. Oh, well, sorry. You add them all up. I'm going to need multiple people. So everybody should be grabbing their calculator right now and typing in these 12 numbers. And tell me what you get after you add them together, but before you divide by 12. This is my least favorite part about finding measures of center. Seth, what'd you get? 312, 312, 312, 312, 312. All right, I like it. So 312. And there are 12 numbers up there. So we're going to divide that by 12. Seth, I'll let you do the honors. What's 312 divided by 12? What is it? 26. Okay, so that's the mean. By the way, 26 would be right around this area, which has been shifted up a little bit by the outlier. Okay. The median, since there are 12 numbers, I can expect how many numbers to be in the middle? How many numbers in the middle? 2, because there's an even number of them. Those numbers are going to be 24 and 25. And what's the average of 24 and 25? Xander? 24 and a half, exactly. So my median is 24.5. So right now they are 1.5 units apart. Let's see if that changes when we take the outlier out. So now we're going to do this all again. But 48, the old person, is not going to be part of it anymore. Now there are 11 numbers. Now there's no 48. So instead of adding all 11 numbers up again, I just take 312 and subtract away the 48. It's not there anymore. How about 264? Can someone tell me what 264 divided by 11 is, rounded to 1 decimal place? It's just 21, okay?
24.
Oh, 24, okay, I was gonna say. So it had an effect of 2. It brought the mean down by 2. The median. Well, now that there's 11 numbers, how many numbers will there be in the middle? Exactly 1. What is it, Alex? It's 24. Oops, put it in the wrong way. So the median is affected, but only slightly. I think last time it was only affected by 5 cents. This time it's affected by 0.5. Okay. The median is the one that has the least amount of effect. Well, the mode is still the same. It's what was it, 22 and 25 in this problem, and 27. There are 3 modes. 22, 25, and 27. Yeah. So the mode's not going to be affected, but I don't really use that one as my best measure of center. Yes. Mm-hmm. All right. We have accomplished the end of our notes. You guys can go ahead and start your big ideas homework tonight. Algebra 1, section 11.1. And yes, you need a wood paper because you're going to have to line all those numbers up to find your median. And it certainly helps with your mean as well.